Hi everyone, today we'll be talking about a surprising geological discovery, an active mud volcano recently found in the depth of the Norwegian Arctic waters, 400 meters below sea level. The discovery was made by a team of researchers led by the Arctic University of Norway based in Tromsø, and we are very pleased to be with Giuliana Panieri, full professor of geology at the Arctic University of Norway, and Irene Viola, master's degree student in geophysics for natural risks and resources at the Department of Geosciences of the University of Padua, currently in Norway for an internship and her work thesis. Good morning and thank you for being with us.
Thank you.
Good morning.
First of all, Professor Panieri, I would start by asking you to describe more in detail this particular active mud volcano and how did you discover it, but also what information can be gathered by it.
Yeah, thanks for the question. This project, the project that is the overarching umbrella of this expedition, it is called ACMA, which stands for Advancing Knowledge on Methane in the Arctic. And this discovery was made during an expedition, which is organized, as I said, within this project. We had an expedition in May this year on board of the research vessel Kronprins Haakon, which is a national infrastructure. And during this expedition, we were focusing on sites in the Barents Sea, so locations which are characterized by natural methane emission. The reason for that is because this expedition, which has scientists and students on board, had the main goal to better understand what is going on when there is methane emissions naturally emitted from the seafloor. And one day we were focusing on an area which is, as you said at the beginning, between 350 and 400 meter water depth. We were focusing on an area where we knew that there were big craters, so big depressions at the seafloor, and also indications of active methane emission. So it was a discovery, but the Borealis mud volcano, but we were kind of targeting sites with methane. But of course, we didn't expect to see what we saw. We didn't expect to see Borealis, but it was very interesting while we were descending to the seafloor with an ROV, which is a remotely operated vehicle, which is like a robot that we pilot from the vessel. It was very interesting because at 6 meters of altitude from the seafloor, we were seeing cloud of mud, of clay in the water. And we couldn't really understand what was going on. It could have been maybe a bottom water current, remobilizing sediments, but yeah, it was very weird. And because it was so weird, and because scientists are always interested in weird things, we decided to stay there for a few hours, trying to understand what was going on. And then, yeah, after a few hours, basically standing still with this vessel, gigantic vessel, and with the ROV, we at a certain point the water cleared a little bit, and it was much more transparent. The cloud went away, this cloud of mud went away, and we could see Borealis at the bottom of the ocean. It was a surprise. I mean, it was, I don't know how to describe that, because it was really, this is something that you don't expect. That this is something that, I mean, you don't see it very often, and at least at the bottom of the ocean, and yeah, in the middle of the Barents Sea. And yeah, we had the feeling that the planet was really breathing, right? And it was really, really very nice. So everyone was super excited, and people were screaming, crying, because I mean, you could really, as a geoscientist, as a geology, when you see our planet really in action, it's just fantastic. And so many years of studies and research and looking for funding that paid off, in these few seconds. Why is interesting Borealis? Well, it's interesting because, and we are just at the beginning of discovering it, because Borealis is a window to what is going on under the seafloor. So it's basically a window to the interior of our planet, and it will be very interesting to see the results of all the analysis that we are performing, in these days.
And as you said, it was an unforgettable moment, and this is the second active mud volcano ever found in Norway.
Yeah, there is another one, which is Akko Mosby, which is bigger than our Borealis. But and the geological processes, even if maybe now is a little bit too early to say that, but we think that the geological processes that form these two maybe are not the same, and they are very different. I have been in Akko Mosby multiple times, and it's very difficult to see it active. Is a big area, and it's very different. As I said, Borealis is within a crater, so there are a lot of communities. There is also an interesting community of organisms living there. There are some carbonate crust, so it's a little bit more complicated, more complex, if you want to say that word from a geological point of view. So it will be challenging to understand what has happened exactly, and mostly when, because now the one of the big questions that we have is when this was formed. So when this mud volcano started to emit methane.
And as you said at the beginning, this discovery was achieved in the frame of a broader project about natural methane emission. Could you tell us a bit more about this?
Yeah, and this project is a project, as I said, named ACMA, and is a project funded by the Norwegian Research Council. This project has two main focus. The first is science, is research, and the second one is education. So during this project, what we have done and what we are still trying to do is to develop new knowledge covering several aspects related to natural emission of methane in order to develop new courses, new activities involving students. And students are always with us in the planning of the expedition, in running the expedition, and they are involved in all the activities which we do on board. And the idea here is really to co-create knowledge together with the students in order to train them, to train the students, the next generation of scientists that will work on these processes in the future. What is interesting here is also the interdisciplinarity. So during the life of the project, we have involved university and research institutes from all over the world. So it is a very interdisciplinary project, because we really want to have this holistic approach to geological processes, but we also want to train the students to have this holistic approach when they investigate, when they study whatever process or phenomena.
Irene, you are among this team of researchers, and could you tell us something more about the experience that you have been carrying out and about also the role that you played in this scientific mission?
Well, my main role, as Juliana said, was to learn, to understand how cruise works, and to learn how the methane emission connect all the scientific aspect from very different discipline. And it was really amazing because you are on a vessel with some of the best scientists about Arctic and methane emission in the world. And you are helping everyone, everywhere. So you process geophysical data, and you acquire geophysical data, for instance, for me. But together with the geophysical data, you deal with the sediments, but you deal also with the physical parameters, and you deal also with the biological sample, never handled them, but it was really interesting also because you never do biology. I'm a geophysicist, so no idea of marine biology, and it's very interesting because you have all these amazing scientists with you that were really nice, and they explain you everything, and you can really feel the multidisciplinary connection in between all the scientific area. You can really understand that everything, you cannot take out only one aspect. You have to learn to consider also the other. Also, if you just study the geophysics of that area, but you have to know that there are other aspects. They are directly connected, and they can also help you to understand the geophysics or the geology or the biology. So it is very interesting. It was an amazing experience.
And what is the topic of your thesis for your
My thesis topic is related to another area of study, that is the Western Svalbard, the Vestnesa Ridge, that was investigated during last year cruise of ACMA, so ACMA 2. And my, let's say, my main aim in my thesis is to use geophysical data to understand the dynamic of fluid flow migration and the thermal processes that lead to the formation of the gas hydrate in the area.
Last question for Professor Panieri. What are the next steps in the project?
Yeah, well, the next steps are first of all to help and support and work with the students now on the data that I have collected in order for having them finishing their master project, a PhD, but mostly helping them to answer the questions that they have. And then we're already planning an expedition for next year because we would like to go back to Borealis and spend more times. Now we have a little bit of knowledge about what it is, but not enough to fully understand what is going on there. And then, yeah, looking for funding because we need funding, we need resources to support the expedition, to invite students and to give the possibility to students and also scientists to join the expedition, because we need, as we said, we are very multidisciplinary, but we are not able to do everything here. So we need to invite expertise from all over the world. And yeah, so mostly looking for some resources, submitting proposal every second week, and hopefully one of those will go through. But yeah, so this is what we are doing right now, and of course writing some papers on the data that we have collected during all the ACMA project.
Well, we wait for updates about the results of the analysis, and congratulations for the discovery and for your work in general. And thank you again for this interview.
Thank you.
Thank you.